Welcome to the Road to Accountable AI. I'm Kevin Werbach, Professor of Legal Studies and Business Ethics at the Wharton School of the University of Pennsylvania. For decades, I've studied emerging technologies from broadband to blockchain. Today, artificial intelligence promises to transform our world. But AI won't reach its potential without accountability, mechanisms to ensure it's deployed in responsible, safe, and trustworthy ways. On this podcast, I speak with the experts leading the charge for accountable AI. Tim O'Reilly is founder, CEO, and chairman of O'Reilly Media, a longtime producer of books, online learning, and conferences about emerging technology, and partner of O'Reilly Alpha Tech Ventures, an early-stage VC firm. But that really doesn't do him justice. For decades, Tim has been one of the leading thinkers in the tech world, responsible for developing concepts such as open source software, Web 2.0, and the maker movement. And now he's thinking hard about the implications of AI and how to address the challenges it poses. He's the co-principal investigator of the AI Disclosures Project under the Social Science Research Council and author of numerous recent articles on the topic. I've known Tim for 25 years, and as you'll see, he always has fresh insights on where tech is going and where it's coming from. Tim, welcome. Always great to talk to you.
Great to talk with you too, Kevin.
Both of us have been following emerging technology for a long time. Let me just first ask you, how do you think about AI? What kind of innovation is it? How significant do you think it is?
Well, I would start by putting all sort of great waves of technology innovation into one frame, computer technology innovation. And that is the increase in the ease with which humans are able to communicate with computers and get them to do our bidding. It's as simple as that. You think back to ENIAC, where they programmed it by making physical circuits. And then we got to stored program computers, but you put it in the program one bit at a time. And they got the switches on the front, and then, punch cards and, mag tape for storing programs. And there was this sort of priesthood who could do these very difficult things. And then you had this big breakthrough. Well, first of all, you had a breakthrough with assembly language and then higher level languages that output machine instructions without people needing to write them directly. And then you got, interpreted languages that made it really easy. And then you had things like the PC, which made it possible for anyone to have a computer. And suddenly there were millions of people doing these things, writing programs. And, that exploded. And then you really got something really new, I think, with the web, which was where you could actually create documents that called programs. And so that was like you could basically make an interface out of a document that was the kind of thing that the humans exchange with each other. And people don't recognize what a big step forward in interfaces that was. In some ways, it was even bigger than the GUI, which of course the graphical user interface, which of course made things simpler. And so now we're at a place where we can just talk to these things in plain language and they can start to do what we want. And if you look at the history, every time we've had one of these advances, more people could use computers and they could do more things with them. And so it's profound. It really is profound. It's basically going to grow the market. And I don't just mean in the number of people who can use it, but in the number of things that they can do. And, again, you can look at other, technologies. You read some of the early history of the automobile. And it's like, if you want to be an automobile owner, you had to be a mechanic, And now you're at a point where you can't even be a mechanic because that's going too far, maybe. But, there are certainly some interesting parallels.
Yeah. Well, so what is there anything we can learn from, at least in computer technology, those prior shifts that can help us in engaging with the issues that are coming up now with AI?
Oh, absolutely. First off, people underestimate them and then they overestimate them, and in some ways this sort of thermostatic kind of process, just like in politics, I guess, in which, people try to have this grand narrative and the world sort of stumbles forward in unexpected ways. I think if you look at, for example, again, I think back particularly on, my early career was very shaped around the World Wide Web. I mean, it was there before that, but an open source software, and
Hmm.
people
Sure.
got a lot of things wrong.
Yep.
My whole battle with I mean, I convened the meeting where the term open source software was adopted, but I was kind of an outlier in that everybody was focused on licenses, and I said I don't think licenses are the issue. It's actually, we have networked enabled collaboration. We have what I called the architecture of participation, the design of systems that people could make small pieces of, and they work together. Sort of
Hmm.
open architectures, and kind of looked at the difference. There's this great line I remember seeing on the internet early on: the difference between theory and practice is always greater in practice than it is in theory. And I don't know who said it, but it's brilliant.
Hmm.
Because always you have people who have this sort of theoretical construct. And the same thing with hypertext. It's like when the World Wide Web came out, all the pundits said, the hypertext pundit said, this won't work because it only has one-way links. It doesn't have two-way links. It has to have two-way links. And of
Hmm.
course, the one-way link thing was part of what made it grow so explosively that it didn't. You could just get a 404 if the way
Yep. Hmm.
um, we stumble forward, and there'll be some innovation, and then somebody else will build on that innovation. And I guess this goes back. I think it's interesting because Ethan Mollick, who's one of my favorite observers of AI, has become a fan, like I have, of James Besant's work on the Industrial Revolution.
Hmm.
Where he basically said, why does it take so long for new innovations to spread? He says, because people have to learn how to use them, and you need to build communities of practice, and you have to have people pushing on it and innovating. I do think that there's an issue now which we didn't have before. And I first wrote about this with regard to where I think Silicon Valley went wrong with its blitz scaling. Reid often
Hmm.
calls it blitz scaling. This idea that companies should race to get market share, and that VCs should basically invest in them so they can do that. And I describe this with Uber and Lyft. In some sense, the market didn't pick the winners. The right winning business model didn't
Yep.
evolve. What happened was the VCs flooded the market with capital. They picked a couple of winners and a couple of early business models. They got their money out because these companies went public, and then companies were like,
Yep.
"Oh, actually, we have to raise prices," and and
Yep.
and now we're starting to have that period of experimentation, and you have that same problem of uh, the winners have already been chosen by the massive amounts of capital. So it's kind of like we celebrate this idea that we have this innovation market, but increasingly that innovation market has become kind of a kind of central planning by a small number of very deep pocketed companies.
Right, and given the extremely high costs throughout the entire
Mhm.
stack for developing some of these AI models, what can we do now to avoid that kind of very concentrated future for AI?
Right now, we're in the AOL stage of AI, is a way to think about it. We've got these big centralized players, and what's waiting in the wings, I think, is this alternate world in which you have cooperating AIs that are, potentially trained on specialized data. And people are starting to say this. There was an article I saw recently that said, Sam Altman's real rival is Jamie Dimon. Because JP Morgan's sitting on this
Yep,
huge, they're working a lot
yep,
on AI, they're sitting on this
yep,
huge class of specialized data that's not
yep,
available to any of
yep,
these guys.
yep.
And so they can
And they've
now,
got the capital. They've got a $10 billion a year IT budget.
yeah,
So
exactly.
yeah.
So, there's sort of an interesting question there. Does that, play out? But in general, it goes to this sort of question that I think about, because of course we
Hmm.
started building things at O'Reilly.
Hmm.
We have much smaller than J.P. Morgan's, J.P. Morgan Chase, but we have a business where we have a
Hmm.
body of intellectual property that, in
Hmm.
theory, has not been accessible to the models for training. I think in practice it probably has been. They probably got it by hook or by crook, but we don't know that for sure. Which is, of course, why I do think that companies should be required to disclose their training data, at least like if only in the form of, do you have my, do you have my content, you know,
Yeah.
queries, just like we have with privacy,
So many things seem inevitable in hindsight, and
hmm
I'm sure you talked to lots of people who weren't there in the early days
yeah,
of the web or even the days of
yeah,
Web 2, just assume it
yeah.
couldn't have been otherwise. Now we're in this period where it seems like there's some possibilities. So are there things that regulators should be doing, that companies should be pushed to do, that might make it more likely to have that more distributed future?
Well, one of the things that I think we could and should do is have more disclosure. Now, when
Hmm.
I say that, a lot of people, they go, "Oh, disclosures don't work," and what they're thinking about are things like, you get your prescription. There's this long, piece of paper that you peel off and you throw away that has a bunch of illegal gobbledygook and or whatever, or even food labeling. There's a little bit of value. Okay, how many calories is this, and so
Hmm.
on. What are the ingredients? Uh, but there's a different kind of disclosures that I think people don't really think about. That really
Hmm.
is a lot closer to kind of communication standards. Like TCP/IP
Hmm.
is a kind of disclosure. It
Hmm.
says this is the format for a particular kind of thing, and you can build to this.
Hmm.
And in a similar way, I've been thinking a lot about the analogy to accounting standards,
Hmm.
which is really, how do you manage money? And we standardized that back at the beginning of the 20th century. And but the standards were based on what people actually did. Go, okay, how much did I take in? How much did I spend?
Hmm.
And double entry accounting had been around for since the 13th century, and had been refined quite a bit. But it wasn't, there were a lot of people who were a little dodgy about it, and so in the early days of public companies and securities, they went, wait a minute, we got to actually make sure that people follow the same rules in describing the finances of their business.
Right.
And when in the last few years, I worked on this project around trying to think about what I was calling algorithmic rents, and how
Hmm.
big tech companies use their algorithms to extract rents from their marketplace and their users. The idea of attention, control over attention being used to then extract money from various other parties, um, and sometimes unfairly. But in the course of that, one of the things that we thought about, we kind of came across, was this idea from accounting of segment reporting, which is this idea that was introduced in the 1960s, that it was in the age of the first industrial conglomerates, where they were saying, okay, if you have some segment of your business that's more than 10% of your profit, you need to report it separately.
Hmm.
And so when we started thinking about internet companies and how opaque they are, you go, oh, well, how interesting would it be if we said to Google, okay, you need to tell us certain things about your 9 properties that have more than a billion users, and we don't care that you tell us they don't have revenue associated with them, because that's the old measure, was revenue, you know.
Hmm.
And the question, and it's pretty clear to us now, that market power in these internet conglomerates is not associated with some of the old inputs and outputs, right? Google Maps is a great case in point. It actually is probably a bit larger in its revenue than, it's like, if you look, it's about $4 billion by most estimates. So it's bigger than Garmin, it's bigger than
Yeah.
Esri, it's bigger than Autodesk mapping stuff. Um, so it's big in its market, but it's a rounding error for Google. But regardless, it's got 2 billion users worldwide. It's an
Hmm.
enormous source of market power. If you think about what's the purpose of those financial disclosures, what do they do? They enable what I think I love this term from Jack Clark of Anthropic and Gillian Hadfield, of regulatory markets. They wrote a paper on this.
Hmm.
And I probably taken their idea a little further. Maybe I'm going beyond the way they thought about it. But if you think about, part of what enables the regulatory market of finance are generally accepted accounting principles
Yep.
and the European equivalent, which is the fact that there's now a market of accountants and auditors who all do the same thing.
Sure.
And that's a lot like, as I said, when you build networking equipment, it all does the same thing, and that was how the internet grew. And I remember back when my friend Dan Lynch started Interop, it was a
Yep.
conference where people came
Yep.
and all the computers had to talk to each other. They,
Hmm.
and
Yeah.
the
Yeah. Which was a
idea
big deal
was
at that.
like,
Yeah.
you propose a standard, you got to
Yeah.
show us three
Yep.
independent interoperable implementations. I always have in the back of my mind this great quote from the famous computer scientist Donald Knuth, who once said, "Premature optimization is the root of all evil." you know? and and there's a way that a lot of the regulations that are being proposed are premature optimization.
Would you say that something like the European AI Act is a premature regulatory optimization for AI?
Let me put it this way: if regulation was as easy to refactor and change and update as you learn new things, as you see what happens, it would probably be okay. The reason it isn't is you sort of incur a kind of societal technical
Mm-hmm.
debt, with when you have a set of rules that don't actually work and are hard to change. And that's one of the advantages that we have with technical standards, because they're fundamentally focused on outcomes, and if they don't work, they lose in the marketplace or they're adapted. Despite what I said earlier about the big money players
Mm-hmm.
making it a less competitive market than it might otherwise be, we have some really interesting cross currents. I think Anthropic is the idea that a bunch of people said, OpenAI has lost its way with regard to AI safety.
Mm-hmm.
We're going to do it better. But then they're also doing a lot of other things better too. So you got some really interesting competition there. I think that Google has been, like if I rank the big players here,
Mm-hmm.
uh, you know, OpenAI is definitely in the move fast and break things camp. Like we're going to be dominant. We're going to do it however we can. Anthropic is, it is a really interesting alternative, and
Mm-hmm.
Llama is a really interesting alternative. And,
Mm-hmm.
and then of course there's all the smaller open source
Yep.
models and other models being developed. But I do think we are having some competition there, you know, but it's still not at the moment. Again, I think back to my computer history, everybody was focused on the hardware battles, and they were only paying attention to that. So
Mm-hmm.
here's AT&T, they're going to have a PC, and
Mm-hmm.
and then along comes Michael, and the big companies all had their personal computers, and there was a lot of innovation, but like some of them were just like Michael Dell comes along, he's like a kid in a Texas college dorm room, and he's like, I'm going to start assembling these things
Yep.
and selling them by
Yep.
mail order,
Yep.
and becomes a real wild card. And I think there is at least the possibility, as uh, when you think about possible futures, one of them is the one that's being advertised, which is we have to keep training on more and more and more and more data, and it's going to be more and more and more expensive.
Mm-hmm.
And then there's the fact that the smaller models are catching up,
Yep.
and that maybe you're seeing the benefits of the current spending level off, and this stuff will be commoditized, and then we'll start to see the real innovations happen, because
Mm-hmm.
it's not going to be constrained by a few companies who are like, okay, we have to dominate and
Yep.
then we have to monetize. And I guess that goes to something else that regulators could do. And again, I think about this not in terms of regulation that specifies what you can and can't do, but regulation that specifies what you have to tell us.
Mm-hmm.
And so, for example, if you were like caring about certain one axis of AI safety, which is addictiveness for kids, you wouldn't necessarily say you can't. Well, you could. I mean, China has literally limited social media use
Yep.
for
Yep.
kids. You could take that approach, but you could also say you got to report to us, you know, uh, what kind of engagement patterns you have and what you're doing to maximize it.
Yeah.
So that it was pretty clear that like, okay, like that case with the kid who committed suicide, it's like, could they have known that? That the fact, here's this kid who's
Mm-hmm.
clearly addicted,
Mm-hmm.
And should they have guardrails against stuff like that? And how would we know, like if they were egging him on, they're going, oh great, this is a really great engaged customer, like what are their optimizations for engagement, for example? And so if you look at social media, once it started to optimize for engagement,
Mm-hmm.
certain bad things happen,
Sure.
and you look at, the work that we did on algorithmic rents. It was sort of like, okay, we have this knowledge because of a lot of consultants who studied search engine optimization. And we have a lot of sense that companies like Google and Amazon got really good at search, i.e. giving people the answer they really wanted. And so we were able to do a study that said, okay, Amazon advertising no longer gives you their best result. It gives you somebody paid for this result, and that result is 17% more expensive and 33% lower in ranking than what their actual best result is. And so whether what you want to do about that, I don't know, but knowing it is pretty useful. And knowing that that companies are, like if when you have like if companies have to sort of show, yeah, we were really putting the pedal to the metal on this risk factor, as opposed to we're actually moderating it and managing it. I think there would be some, like, you don't have to kind of have the law come down and say you are going to be punished, because the market will punish people because somebody's going to sue them, and you'll have the information to say, yeah, you were doing this bad thing and we can see it in your numbers, and it caused this harm. And so I kind of feel like, right now we have this sort of crazy ass approach, which is sort of fed by all the existential risk people.
Mm-hmm.
That's akin to saying, okay, let's regulate cars that can go over 150 miles an hour, but no other cars, and let's do a bunch of crash test dummy kind of testing, but have no other regulations. And you think about auto safety, and yeah, HTSA does crash test dummies, and how long does it take
Mm-hmm.
for a car to brake at a particular speed, and what's its crumple zone, all this kind of really useful stuff, which is a kind of model safety. But we also think about driver education and licensing, speed limits, and the speed limits aren't, one size fits all. They're different on different kinds of roads. And you could say, okay, well, this is how, what we think is safe in this market or that application. You could be thinking about, again, I say this idea of licensing. Jillian Hadfield, I think, has really been big on this notion of,
Mm-hmm.
hey, AI models ought to be registered, just like cars are registered. They have a license plate, and guns have a serial number, and models, no, not so much. Again, there's a lot of lessons we could take from what is the overall infrastructure of that allows, first of all, allows you to inquire when something goes wrong. Again, think about black
Mm-hmm.
boxes and
Mm-hmm.
airplane crashes. There's a lot of interesting infrastructure that makes a system regulatable as we
Yeah.
start to see problems emerge. And I think that's an interesting conversation I've been having with Vince Cerf. He's
Mm-hmm.
like, one of the really interesting questions that we ought to be asking is this system regulatable at all?
Mm-hmm.
And how would we make it regulatable if it isn't? Because it's certainly possible that you can build technologies that are fundamentally not regulatable, and then we have to ask ourselves, do we want to do that?
Yep. Yep. Yeah, I think Larry Lessig called it regulable back in the early internet days, and we have these same conversations in blockchain and so forth, and it's an
Mm-hmm.
important point. Let me ask you one more thing,
Yeah.
which is, where does open source fit into this? Because as you know, there's this big debate about open weight models and the risk that
Yeah.
they provide, and in some ways that seems like it's more disclosing, but on the other hand, it's out of the control potentially of the developer what people are doing with it.
I guess I'm not sure I have a clear answer on
Hmm.
that. In general, I'm a fan of the way that open source makes a market more competitive. And I do, obviously there are people who have a lot of concerns about national security, for example. And I guess the point is that Meta has made is, hey, look, this stuff is, we have a lot of industrial espionage, and as in every version of cybersecurity and everything else, a notion that you're just going to build a wall and keep people out is not generally that successful in the end.
Mm-hmm.
So you're better off building a robust system that can handle the fact that people know things.
Okay. Well, so last thing is, we don't have too much more time, is so are you optimistic that we will come up with an approach that makes these technologies appropriately regulable? And if so, what gives you that optimism?
Well, first off, I don't think they're as dangerous as the people who make the big existential risk arguments think. I don't think we're on a path to AGI right now. Now, we might be. I could be wrong about that. There's a bunch of different risks. Yeah, some of them are, if you look at the whole CBRN area, that's
Chemical, biological, nuclear weapons.
On top of that, like to what extent does this amplify existing risks? In cybersecurity, bioterror, et cetera, et cetera. That's all, really important work. And but it's not specific to AI. It's just it's like, okay, we have these frameworks for thinking about this, and even there, Narayan and Kapoor, in AI Snake Oil, talk about the notion that, hey, well, if you're worried about bioweapons, physical biosecurity and access to the kind of equipment that you need is actually probably more important than people can get information about how to do it. So again, it's where we got the wrong focus there. But I think there's also a class of risks, and this is really the focus of my work in this area, which is this notion of commercialization risk. And there's two parts to that. And one is, do companies have the incentive to do the wrong thing? So the move fast and break things risks. Here is this race for monopoly, and like companies, they're basically going, oh yeah, we're all about AI safety, and then they fire their AI safety team, because really they want to win. And I think that is a real risk. But there's another risk, and the example, I try to use examples from the past, and like two great ones come from the social media era, and the first is the Myanmar massacre. And it was not the thing. The big takeaway I have there is not Facebook had guardrails against hate speech. They just didn't work in Myanmar because they didn't understand the language. Their systems weren't tuned for the language. And so that, I call that deployment risk. So, and again, it goes back to this, the difference between theory and practice is always greater in practice than it is in theory. In theory, we have guardrails. Do we have them in practice?
Yep.
And that's the question that regulators should be asking. It's like and this goes back to this analogy. Okay, we tested we did the crash test dummy stuff, but now we're not looking at the data from the real world, and we're not even thinking about the data from the real world. And so, like, to me, and again, that goes back to disclosures. You'd kind of go, hey, you say you do AI safety. What does it look like? What are you actually doing? And that's, again, a lot of what our project is trying to focus on, which is what should regulators be asking to see and to know about what a company is actually doing. And that requires understanding, okay, what does safety engineering for AI look like? And how much is a company spending on it? Are they doing it in all the markets they operate in? Or just some of them? Like they go, oh yeah, well, we're offering our services around the world, but we're only doing all the safety engineering in English, in the US, or whatever, because that's our biggest market. That's the kind of thing that I would be thinking about. A similar one is this huge, set of questions around what do your third-party developers do? And this came out to me, and again, I haven't dug into it. What are companies doing across the board? But it's a super interesting area to me, which is there was this report from Proof News, Julie Angwin's outfit, about election misinformation. And, the main result was sort of obvious. Okay, these things were pretty shitty at give. They basically did red teaming with election workers who knew what questions people typically asked. And they said, oh, well, you're giving misinformation about half the time. But the most interesting result in the paper to me was that when pressed, the model developers said, oh, and they tested a bunch of models in parallel using an AI API harness, right, where they would submit all the same questions. And they were told, oh, your results don't show our real guardrails because you were using the API. And with the API, it's the responsibility of the developer. And I go, oh, that's like, oh, yeah, we have these protections against we privacy protections. But guess what? Cambridge Analytica is this huge leap. It's like, so if you're just saying it's the responsibility of the developer, is that really, that's just like you're wide open.
All right. So much more we could talk about, but I think that's a good place to land. Always fascinating to speak with you, Tim. Thanks so much.
All right. Thanks a lot. All right. Great talk with you too.
This has been The Road to Accountable AI. If you like what you're hearing, please give us a good review and check out my Substack for more insights on AI accountability. Thank you for listening. This is Kevin Werbach. If you want to go deeper on AI governance, trust, and responsibility with me and other distinguished faculty of the world's top business school, sign up for the next cohort of Wharton's Strategies for Accountable AI online executive education program, featuring live interaction with faculty, expert interviews, and custom-designed asynchronous content. Join fellow business leaders to learn valuable skills you can put to work in your organization. Visit execed.wharton.upenn.edu/ACAI for full details. I hope to see you there.